Today we're going to be solving ratio and rate problems. A ratio compares values. It says how much of one thing there is compared to another thing. I see in my little drawing here 3 triangles and 2 squares. The ratio of triangles to squares can be written as 3 to 2 and not the other way around. Order really matters in a ratio. But I can also write 3 to 2 as 3 to 2 in words, or like a fraction, 3 over 2, or 3 to 2, because it basically is a fraction. That's what a ratio is. A rate is a special type of ratio that compares 2 unlike units of measurement. So in my little speed limit sign here, my 2 unlike units of measurement are miles and hours. So my rate is 25 miles per 1 hour, because that's what per means. For every one. So 25 miles per hour. All right, now to my problem. Jack drove 325 miles in 5 hours. How many miles per hour did Jack drive? Jack will drive 520 more miles at the same rate. How long will it take Jack to drive the 520 miles? It looks like I have 2 parts here. The first part wants me to find the unit rate. How many miles per hour did Jack drive? I can do it like this. I can just start by dividing 325 by 5 and get 65. Or I can write it like a ratio. It might help to see things a little bit better that way. 325 miles over 5 hours. So for every 5 hours, he drives 325 miles. Let's set that equal to something, I don't know what it's going to be, over 1 hour, because I want the miles per hour. So in order to get from 5 hours to 1 hour, I need to either multiply or divide. If you said that you would have to subtract 4 hours, you would be right, but you wouldn't be able to get an equivalent ratio out of it because we got to do the same thing then to the numerator. So 5 divided by 5 is 1, and I can do the same thing up here. So 325 miles divided by 5 is 65 miles, just like we got before. So how many miles per hour? 65 miles per hour. All right, so Jack will drive 520 more miles at the same rate. If we want to figure out how many hours that's going to be, then I don't know what's going to go on the denominator, but I know that 520 miles is going to go in my numerator. So how do I get from 65 miles to 520? I know I'm going to be multiplying by something because 520 is bigger, but I don't know exactly what. To figure out what that's going to be, I can just go over to the side here, 520 divided by 65, because multiplication and division are inverse operations. And since I have a calculator, I figured out that it was 8. So I'm going to multiply my numerator by 8, and I'm going to do the same exact thing to my denominator. 1 hour times 8 is 8 hours. So how long? 8 hours. And what you see here at the bottom is 3 equivalent rates. Now on to my next problem. Susan can buy 6 flower seed packets for $2. If all the seed packets cost the same amount of money, how many packets can Susan buy for $10? So another way to solve ratio problems is by using a ratio table. So I can list out all the possible combinations of flower seed packets and how much they cost. So let me do it until I get up to $10. So I have packets, and I have dollars. Let me make a couple options for myself. 6 flower seed packets and $2. And I can say, okay, what if I want twice that? Do the same thing to packets and to dollars. So 12 packets would be $4. Or I can just count by 6s on the left and count by 2s on the right. Because I know that for every 6 packets, I have to pay $2. So 18 packets for $6, 24 packets for $8, 30 packets for $10, 36 packets for $12, 42 packets for $14. So they asked me how many packets can Susan buy for $10? Well, my answer is already on this chart. 30 packets for $10. Awesome. Now, there's another way that I can solve this problem. I can also use unit rates, just like in the first problem. So I know that she can buy 6 flower seed packets for $2, so that's my rate. 6, I'm going to write FSP for flower seed packets because I'm kind of lazy. And I'm putting the dollars as my denominator because I know that I'm going to have to get my rate down to $1. So let's see. How do I get from $2 to $1? Divide by 2, of course. Got to do the same thing to the numerator as well. So I can get 3 flower seed packets for $1. And now I know that I have to somehow get to $10. So let's set that up here. $10 for some unknown amount of flower seed packets. So how do I get from $1 to $10? Well, that's easy. I multiply by 10. And that's why I really like solving problems using unit rate, because it's easy to get from $2 to $1 and then from $1 to $10 than it is to try to figure out how I get from $2 to $10, because it's not always going to be as easy as $2 and $10. So let's multiply by 10 in the numerator. I have 30 flower seed packets for $10, just like I did when I used a ratio table. Now you know everything you need to know in order to complete today's assignment.